Hey, so I ran out of time. Let's see where I was. So on last video. So I hooked up pin 15 on the output, or sorry, input, pin 15 on the input, switch 15 right here to pin 9 on the chip, right here to pin 9. Ooh, look, you can see pin 8 is right there. Pin 9 is right there. You see, because it kind of like lines up. If you line up this thing with right here in the notch, huh? Mr. Worst, be a better teacher. Come on. Okay, so switch B, which is 14 down here. That's why I've labeled it as. You can't see it. It's probably too small. 14 is hooked into pin 10 on the chip. And the output, I don't have the output. So pin 8 goes up here to the out. And what did I say out was going to be? Out 7. Okay, so I'm going to go pin 8, which is right here. Liar, it says 14. And I'm going to go up to switch 7, and I still need power. So pin 14 on the chip, which is right up here next to the notch, which is right here, goes over to power. Boom, we're wired up. Okay, so we're going to test it now using this truth table. So switches A and B down here at the bottom, off. Okay, what are the, oh, let's power this thing up. Okay, so we got a power up simulator. Okay, so if they're both off, the output is off. So output is 0. I turn switch B on. So A is off, B is on, output is 0 still. That's good because that's how an AND gate's supposed to work. The next one's supposed to be off. I could cheat and I just could write a 0 here, but let's check. So A is on, B is off. 0, correct. Okay. And then the last one, I saw it flash, it worked. Okay, so A and B on, X, the output, A times B is on. Perfect, it works. Okay, so going to go a little bit faster for these other ones. I went ahead and I put in the wiring diagram for each of them. So we have an AND gate here. I chose the top one on the chip. So A is going into pin 12, B is going into pin 14. I keep on using these switches down here. I think that's helpful to use the same switches. It means you're going to have to delete some lines here. The way you do that is you just remove connection. You can remove it. That's the same way you add an IC. So go ahead, put the chip in, the 7432 chip, the OR gate. You're probably going to have to log into Falstad to do that. Okay, so remember to log into DeldSim in order to do this. Okay, so we're going to put this one in. So you're going to do the OR gate, wire it up. For the NAND gate, remember it's got a reindeer nose on the front. I chose the first one. You can choose any one that you want. Okay, so on the first one, the inputs are on pin 1 and pin 2, outputs on pin 3, and then you test it. Okay, you test over here, and I'll do some fake testing here at the end. And here's a NOR gate, reindeer nose on the front. The NOR gate is in a different orientation. See, look, they're headed to the left, not to the right. Like up here, everything was headed to the right, so pins were 1 and 2 in, 3 out. This one is 1 out, 2 and 3 in. Make sure that you remember that. Okay, I'm going to do some fake testing now over here. Okay, so let's say I go wire this one up, the OR gate. I should get 0, 1, 1, 1. If you don't, something's wrong. Okay, in fact, later when we do other labs, we'll have like a should be column and then an actual experimental. So like it should be 0, 1, 1, 1. I should add another column there for experimental. What is your experimental output? NAND gate, this should be 1, 1, 1, 0. That's what your output should be. And lastly, the NOR gate, this should be 1, 0, 0, 0. Yes. Okay. Good luck. Hope you got this. Remember, DeldSim, if you can't see the chip when you go to add IC, it means you haven't logged in. You need to register. Register and log in order to see these other chips. We're not going to do the ones that cost money down here. Yeah, choose a college that you might be interested in going to for your login. Cool. Hope you have fun doing these chips. Call me if you need help. Like always, rock and roll.